You know, AI isn't just something you see in movies or in high-tech university labs anymore. It's actually being taught in high schools right now, completely changing how we prepare for the future. So today, we're going to take a look at that journey, from the very first line of code all the way to building some genuinely intelligent systems.
This quote from the Curriculums Forward just says it all, doesn't it? The science fiction of yesterday is the reality of today. The whole point is to give the next generation the tools to not just understand AI, but to actually build with it.
So that's the big question, right? How do you go from just using technology to actually creating it? Let's follow the roadmap and see how it's done.
Every great journey starts with the basics. And in the world of AI, the absolute fundamental raw materials are code and data. This is the foundation for, well, pretty much everything else we're about to talk about.
Now, the good news is students don't have to reinvent the wheel. They get to use Python libraries, which are basically these amazing pre-written toolkits that do all the really heavy lifting for them. And here are the two big workhorses. Think of NumPy as your super fast calculator. It just blasts through huge piles of numbers in a flash. And Pandas? That's your master organizer. It takes all that data and arranges it into these neat, tidy tables that you can actually work with.
And the star of the show in Pandas is the data frame. Honestly, if you've ever used a spreadsheet program like Excel or Google Sheets, you already get this. It's just a table with rows and columns that lets you slice, dice, and analyze your data. Simple as that.
Okay, here's a little secret about data science. Real-world data is messy. It's full of holes and mistakes. So a huge part of the job is this four-step cleanup process. You bring the data in, you find all the missing pieces, you fix them, and then you save a nice, clean version. It's not glamorous, but it's absolutely crucial.
All right, so we've got our materials. Now we need a blueprint. In AI, you can't just start coding and hope for the best. You need a structured plan, a methodology that guides you from a question all the way to a solution so you don't get lost.
And this is a really, really important point. Building AI isn't just some chaotic coding session. It's a disciplined, scientific process. Students learn a specific methodology from IBM that breaks down any project into clear, manageable stages. So here's that blueprint in action. It's a cycle. You start by figuring out what problem you're actually trying to solve. Then you go get the data and clean it up. After that, you build and test your AI model. And finally, you release it into the wild and use feedback to make it even better. It's the whole project lifecycle from start to finish.
And that first step, understanding the problem, is all about asking the right kind of question. Are you just trying to describe what already happened? Or are you playing detective and diagnosing why it happened? Maybe you're trying to predict the future, or even prescribe what someone should do about it. Each question needs a totally different kind of AI. Okay, this is where things get really cool. We have the tools, we have the blueprint. Now it's time to build systems that can actually perceive the world, reason about it, and even create things. This is the leap from data analyst to true AI builder. First up, computer vision. This is literally about teaching machines how to see. It's the magic behind your phone unlocking with your face, or a self-driving car identifying a pedestrian. It's even in those apps that can tell you what kind of plant is in your garden just from a photo.
So how in the world do these models learn? Well, a lot of the time, it's through what we call artificial neural networks. And yes, they are directly inspired by the human brain. They're made of these interconnected digital neurons that pass signals back and forth, learning to spot complex patterns over time.
The way these networks learn is kind of like a two-step dance. First, you have forward propagation, where the network takes its best guess. Then comes backward propagation. This is the feedback loop. If the guess was wrong, an error signal travels all the way back through the network, telling each neuron how to adjust itself to make a better guess next time. It is literally learning from its own mistakes. But what if AI could do more than just recognize things? What if it could create them? Well, that brings us to the creative frontier, generative AI. This is where models don't just analyze data, they can actually generate brand new, totally original content.
And here is the perfect way to understand the difference. Discriminative AI is like an art critic. It looks at a photo and tells you, that is a cat. Generative AI is the artist. It understands the essence of catness, and then it creates a brand new image of a cat that never existed before. This is the tech behind tools like DALL-E and Midjourney.
All right, we've come to the final, crucial piece of the puzzle. It is not enough to build a powerful AI model that finds some amazing insight. If you can't communicate what you found, it doesn't matter. And that's where data storytelling comes in.
A great data story has 3 core ingredients. You need the data, that's your solid factual foundation. You need the visuals, like charts and graphs, to make the data easy to grasp. And then you need the narrative, the storyline that weaves it all together and gives it meaning.
And get this, a data story can follow the exact same structure as a great novel or a movie. You set the scene, you build a suspense with your findings, you have a big climax where you reveal the most important insight, and then you conclude with a powerful takeaway. This turns a dry report into a compelling argument that actually makes people want to act.
This all leaves us with one last, really provocative question. As high school students learn to build systems that not only analyze, but also create and communicate, who are they becoming? They're more than just programmers or scientists. They're becoming the authors of new insights, and in doing so, they're shaping the stories of our future.